Just calling a quick audible here. We are getting ready to start the lab, but there's something about areas that I want to share with you. Because I mentioned we do have some more theory we want to cover, but we're going to do that after the lab work. But this I want you to know about now because we're getting ready to use the network command. When we start using the network command here, we're going to be required to enter an area at the very end of the command. And the area that we're going with here is area 0, which is the backbone area of an OSPF deployment. Oftentimes, people don't even refer to it as area 0. They just say the backbone area. And every non-backbone area in the network must contain an interface on a router that has a physical or logical connection to area 0. Now, this sounds, like a design requirement. And I don't know if you've hit any of those in your studies or not, but usually even the Cisco best practices, which I'm going to share some with OSPF with you later here in this section, they'll give you a recommendation of how many routers should be in an area, how many routers or how many areas a router should be part of, that kind of thing. But they are not absolute hard and fast rules. Let's say that there was a limit of 50 routers in an area. Well, when you put the 51st one in the area, nothing's going to blow up. Nothing's going to start going wrong immediately because you put that magical 51st router in there. This is not really a design requirement, though. This is an OSPF requirement. It's a hard and fast rule, and it's one that we're going to keep an eye on as we build our network out, because the thing is, you don't automatically have something go horribly wrong when you start that. When you have a non-backbone area that doesn't have an interface on a router with a connection back to area 0, you don't see a huge message come up on the screen immediately. But routes may go missing, pings may not go through, that kind of thing, and you need to be able to spot it. So maybe we'll see some of that in our lab as well. But one thing, you're going to see some areas here, and in future studies as well, you're going to be learning about more specialized, what I call specialized OSPF areas. And sooner or later, maybe sooner, maybe today, you may just say, hey man, I don't know why we don't just put everything in area 0 and be done with it. I had the exact same thought years ago when I started studying OSPF. And the textbook answer to this question is something along the line of, well, it helps limit the scope and impact of network changes. Well, that sounds great, but what exactly does it mean? What exactly is going on with that? Well, one problem with putting all of your network segments in one giant area 0 is that the resulting databases on your routers end up being larger than they have to be, which slows the overall process down. Both routing, creating the table, and then updating it. And if a router's on the edge of the network, say it only has one path to the rest of the network, that router doesn't need a full OSPF database. It doesn't even need a full routing table. Let's take a look at this situation. Whatever one of those Tonneau OSPF networks router 1 wants to send a packet to, where does the packet go next? It's not a trick question, right? It goes through router 2. That's the only place it can go. Well, in this case, router 1 doesn't need a full OSPF database. We can create a specialized area called a stub, and there are several different kinds of stub areas. But we could create one of those and greatly lessen both the size of the database and both the size of the OSPF routing table on router 1. So those come in really handy, but if we just put everything in area 0, we couldn't do that because a stub area is going to be numbered onto itself. Now also, if all routers are in a single area, that means that every router has to run the SPF algorithm when there's a change in the network. And by using multiple areas and specialized area types, we can limit the number of routers that run the algorithm upon a network change. We like that because it lessens the overall workload of the routers in the specialized area. So basically, by using multiple areas and again specialized area types, the areas you choose, the number of areas you use, it depends on the network. There's no one-size-fits-all solution for it, but these are really the reasons you want to avoid just having one giant area 0. When you just have one area, there's a bigger workload on all of your routers, and there probably has to be. With that in mind, we're going to build our first OSPF segment, and we're going to actually start that in a minute. There's something from the last video I wanted to show you. I know I keep putting it off, right? That's wrong of me, but I did want to show you this. And I mentioned something about what happens when you try to run OSPF and you don't have an IP address on an up and up interface. So let's just say that you sat down at this router and while you were gone, somebody wrote it, right erased your router, reloaded it, and then just put the lab commands back on. I'm not saying that's ever happened here, but it has happened here. So I am saying it. So let's just say that I sit down now and do a router OSPF1, and hey, I get a message, something about failed to allocate unique router ID and cannot start. I know a couple of the letters are a little off there. And it looks like it says cannot tart, but I guarantee you it says cannot start. Well, this is not the kind of thing you want to see first thing in the morning if you haven't had your coffee, even if you don't drink coffee. And the thing is, and this is a great example of it, even, sooner or later you're going to see debug output that you haven't seen before. That'll probably happen in this course a lot. You're going to see a warning message sooner or later that you haven't seen before. And the first time I saw this one, I mean, I'd been doing this for a long time. And, like I said, one day somebody just did a write erase. The addresses were gone. Everything else was gone. But when I came back, it looked up. And this is what happens. I got this message and it's like, oh, the first thing you look at that is, oh my God, something's corrupt. Something's really wrong with the router. It was fine 10 minutes ago, that kind of thing. Well, the reason I'm showing this to you is so you don't have that kind of fit. Because just remain calm, which I did after a few seconds, and you just read the message. And it's even telling you right here, no router RID. There's no RID here. And, your eyes tend to go to the failed, but the thing is it failed to allocate a unique router ID. If the router can't create a router ID for OSPF, it's not going to start. And it kind of looks like it did, right? I mean, it dropped into router config mode, but you know what happens if I run show IP OSPF right now? It's even going to tell me that. The router process 1 is not running. You need to configure a router ID. So, of course, that would be about the time you say, oh, I need to put some IP addresses on here, and we'll go from there. But I did want to show you that good troubleshooting tip, because if you don't bump into it on the exam, you'll bump into it sooner or later. Let's take a look at the segment we're going to build. And the first one we're going to build is between routers 1 and 5. And it's going to be the 10.110/24 subnet. All IP addresses on non-loopbacks, by the way, will end with the router number. It's a good organizational tool to get used to using. And we're going to put them into area 0, our backbone area. What I've done here, and I'll put the addresses back on router 1, obviously, but every router has one loopback. And router 1's loopback is 1111/32, routers 2 is 2222, and so forth. Now, for clarity's sake, I have not included the loopback interfaces in the illustrations because we're not yet OSPF enabling them. We're going to do that later in the section, but not originally. Also, any and all previous OSPF related commands have been removed from every router. So we are indeed starting from total scratch, and that's what we're doing, 10.111 and 10.115. Now, one thing I want to mention here with the router OSPF, and we'll see it in a moment. I've mentioned this process number a couple times. I know you're probably getting tired of hearing it. Let's go right here to router 1. And you see that is the process ID. There's no other value you can put there. The reason I mentioned this a couple of times is that with EIGRP, we also put a number here. But that is an autonomous system number with EIGRP, and that must agree with any downstream neighbors, potential neighbors, before they become actual neighbors. With OSPF, this is the process ID, and it's locally significant only. Downstream routers aren't even going to see it, and they definitely don't have to agree. So if we put process 5 here on router 1 and 55 over on router 5, it's going to work just fine as long as everything else, as far as the timers and the mask, are good to go. Now, the reason we have the chance to set our own process number is that sometimes you'll want to run multiple OSPF processes on a single router. Now, this is a bit of a CPU hit, and depending on how large the tables and the databases get, it can be a big CPU hit. So you definitely want to make sure that you've got a powerhouse router running a multiple OSPF processes. Routes are not exchanged by default between OSPF processes running on a single router. So that may be one reason you would do that, or would be one reason you would do that, is that you could have your serial interface in process 5 and fast Ethernet in process 10, and you don't want each segment to know about the routes you're getting from the other segment. So just wanted to fill you in there on the processes. And tell you what, we're hitting 10 minutes here, so we're going to take a break. I swear to you, we will start this lab when we come back. You needed to know about the areas, though, and I wanted to show you that thing with the process not starting. So I will go ahead and put the IP addresses back on router 1, and we will get started at the beginning of the very next video.